So in order to understand chemistry, we have to understand chemical formulas. And chemical formulas are used to show the number and type of each atom in a substance. So for instance, if we look at hydrogen gas, so hydrogen gas that you can get by taking some zinc maybe and throwing in some hydrochloric acid is actually made up of two hydrogen atoms that are stuck together in a pair. And so I'm going to draw it like that. And the chemical formula we write as H2. And what we do, right, is we write the symbol. So we know that hydrogen is H, okay, which is kind of a giveaway from there, I guess. But what we do to the right is we write a subscript. And sub means under or below, so script is writing. So we write a little subscript there. That's the number of atoms of each element. If we take something like water, water is a hydrogen atom and an oxygen atom and another hydrogen atom in that particular shape. And then we can go ahead and we can say there's two hydrogens, so H2, and there's one oxygen, so we can write O1. So again, we're using a subscript to represent the numbers. And notice that we always write the subscript there to the right of the element symbol. So the 2 refers to the H, not to the O. So it's H2O1 if you like. And if you're thinking, wait a minute, H2O1, I thought it was just H2O. You're quite right. Almost always when there's a 1, we neglect it. So the only time you really write it in is if you want to really emphasize there's 1 and it's very important there's 1, and maybe there didn't used to be 1 and now there's 1. But apart from that, you almost always just kind of scrub it and just write it as H2O. If you took, say, methane, so methane is what we use in our Bunsen burners in the lab to make a nice flame. We'll actually do a lab and we'll burn the gas that goes into the Bunsen burner, and it makes a great flame, and it's beautiful for heating stuff up, and it looks something like that. And so why don't you go ahead and just sort of pause this video and try and write the formula out. So give you a couple of seconds, pause it, and have a go. Okay. Did you get the formula okay? So we've got two things, carbon and hydrogen, and the order you write them in actually matters, but I don't care what order you do it in. So there is actually a pattern. If you read the book, there's a way to do it. You do it from left to right on the periodic table, from top to bottom, or something like that. I actually had no idea there was ever a rule. It's sort of one of those things you just sort of pick up over time. So it doesn't really matter. I'm going to start with the carbon. There's one of them, so C1. And then there's hydrogen, so that's what the H stands for. And there's 4 of them, so that 4, of course, goes subscripted to the right. So it goes below and to the right of the element it applies to. And then because there was just one carbon, right, we really don't need to write that in. So CH4 is methane. Okay, so I got a couple other chemical formulas for you. So here is one, so CH3OH. This is methanol. Sometimes called wood alcohol, and we've got C6H12O6, which if you've ever taken any biology, you've seen that many times. That is a molecule called glucose. And just go ahead and pause the video, and if you like, count the total number of atoms in these two molecules. So how many atoms are in methanol, and how many atoms are glucose? So just pause the video and count how many there are. Okay, well, if you've unpaused the video, right, you're hearing me talk here. It's kind of weird, actually. But what do we have? CH3OH, so that is methanol. We've got, if you like, 1 carbon. So we've got 3 hydrogens. We've got 1 oxygen, and we got 1 hydrogen, right? Remember, we don't write the 1s in. So let's see, that is, we need a lightsaber here, don't we? So that's 1. Right, 2, 3, 4, 5, 6 atoms in total, right? So there are 6 atoms in methanol, whereas if we go to something like glucose and we get our lightsaber out, if I can change the angle of my lightsaber, clearly I'm not clever enough to do it. So there's 6 carbons, there's 12 hydrogens, there's 6 oxygens, so 6 and 6 make 12, and another 12 is 24. So there's 24 total atoms here. I'm not going to try and draw them out, so we can see that the chemical formulas are a very compact way to indicate the number of each element's atoms inside the molecule. Okay, so we haven't mentioned the periodic table yet. If we have, we mentioned it in passing, but I wanted to show you the chart that we call the periodic table. So let me go find it and plug it in here. Okay, so here's the periodic table from our textbook, and this is every single element. This is all 118 of those elements, and no, you don't have to memorize all this information. You don't have to memorize all the element symbols on here or any of the numbers on here at all, but I just wanted to show you a couple things. The elements are organized, well, I'm going to cross my fingers here and say by weight. So that's not quite true. Now, originally they were, so hydrogen is the lightest. Let's get off our lightsaber here, right? So helium's the second lightest, lithium's the third lightest, beryllium the fourth, and so on. There's a couple where that's not actually true, but we sort of arrange them to left to right and then top to bottom. So as we kind of go across a row, we then go down to the next row and so on. There's actually, when we get to element number 57, the 58th one isn't right next to it. We actually pull that out and pull it down below. And so you can imagine this section here actually belongs right here. And you would have to sort of cut the periodic table here and move this side over and squeeze this in. And it just makes for too wide of a periodic table. But what I wanted to show you is that there's something really cool when you do this. You can actually see the dividing line on this periodic table. The one I gave you on the exam won't look quite this pretty and it won't be colored. But very roughly you can say that these elements here, all the way on the left-hand side, are they are shiny. So they can be polished and reflect your light. They are malleable, which is to say you can kind of hammer them out into sheets. They are ductile, so that means that you can go ahead and you can squeeze them through very small holes and make wires. And they conduct electricity well and heat very well. And so all of these elements here, you may have already heard, I'm sure you've already heard this name before, right? We call metals. So everything on the left-hand side of this table here is in metal country. And then there is a line, and, well, that was the eraser. So, okay, there is a line. There we go. On the other side. And those are the blue elements here. And these tend to be poor conductors of orchestras. No, I'm joking. Poor conductors of heat and electricity. So there's a few exceptions. There's nothing here is like hard and fast, but most of them are. They tend to be quite brittle, so if you hit them with a hammer, they smash. So diamonds are made of carbon. If you take your diamond ring and you hit it with a hammer, don't do it. If you do, you'll get lots of itty-bitty little diamonds. And they tend to be quite dull, so diamonds are maybe not that dull, but they tend to not polish and reflect very well. So, for instance, carbon, the carbon inside your pencil, right, is quite dull and boring for the most part. So these are sort of opposites of metals, and so we call them actually non-metals. We'll have quite a little bit more to say about the periodic table. This is just a quick sort of intro here. We'll spend at least a half hour discussing it later. But we have ones that are sort of in no man's land in between the red and the blue lines here. And so these are elements like silicon and arsenic and germanium and antimony. And so silicon especially comes up in silicon chips. And these are what we call metalloids. And I've switched to eraser mode again. So metalloids. I can't remember that. It has two L's or one L. It must have two L's, right? That doesn't look right. Sometimes we call them semi-metals. I always think metalloid sounds like hemorrhoid, so I try not to use that name. If we pick on silicon, for instance, so silicon actually is quite shiny, so you can take silicon and make a wafer out of it and polish it, and it reflects pretty well. But it's actually sort of a mediocre, if I can spell that word, mediocre, is that right? Conductor. So it really doesn't conduct heat or electricity terribly well. It's not atrocious. It's not that good. It's somewhere in between. So these elements tend to be somewhere in between. It's also actually fairly brittle. So even though it's shiny like a metal, it's brittle like a non-metal. So it's like they can't quite make up their mind here. So you should be able to identify metals from non-metals from metalloids by looking at the periodic table. And you will always be given a periodic table on the exam. It will always have these three things. It will have the symbol, it will have a number above and a number below, but it won't have these names on, and it won't have things like periods and groups on, but we'll discuss that later.